Section 5 is geometric series. I can define geometric series and find their sums. Big ideas for this section include, just as with finite arithmetic series, the sum of a finite geometric series can be found using a formula. We have to know the first term, how many terms there are, and the common ratio. A geometric sequence can be modeled explicitly or recursively. The sum of the first n terms is found by this formula. Sum of a certain number of terms equals our first term, a sub 1, times 1 minus r raised to our n value, which is our number of terms, all divided by 1 minus r, our common ratio. A geometric series is the sum of the terms of a geometric sequence. Take note on page 595. Again, this is what we talked about on the take note as well, or on the big ideas as well. The sum of a finite geometric sequence, that just means it terminates. So our first term, and then since it's geometric, we multiply by our common ratio. So our first term times our common ratio, then we multiply again and get r squared, all the way until we get the number of terms that we're looking for. Is going to be our first term times 1 minus r raised to our number of terms divided by 1 minus r. So, what's the sum of the finite geometric series here? We know our first term is 3. So 1 minus, we can find our common ratio. Okay, we know it's geometric, which means we know we're going to multiply. So 3 to 6 is times 2. 6 to 12 is times 2. 12 to 24 is times 2. So we multiply by 2 every time. I don't know what n is though. So we need to figure it out. And just like we did on the arithmetic series, we're going to use our geometric sequence formula to find it. So a of n equals a sub 1, our first term, times our common ratio raised to the n minus 1 power. Here, we're looking for n, but we know the amount of our nth term is 3072. We know our first term is 3. So we're going to try and solve, we know our r value as well. We know r is 2. So go ahead and divide by 3. We're going to get 1024. Now we need to figure out what 1024 is in terms of base 2. So we're going to go ahead and simplify here. I have 2 times 5, 16, which is 2 times 2, 56. 2 times 128, 2 times 64, 8 times 8, which is 4 times 2, and 4 times 2, and 2 times 2, and 2 times 2. So overall here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 2's. So right now I have 2 to the 10th power equals 2 to the n minus 1. And just like when we had our exponential and logarithmic chapter, since our bases are the same, I can write it as 10 equals n minus 1, add 1, and get n equals 11. So that n equals 11, I'm going to plug in. The sum of our first 11 terms is 3 times 1 minus 2, which is our common ratio, to the 11th power, divided by 1 minus 2. Two to the 11th power is 2048. So I'm going to have negative 3, I just divided right here, times negative 2047 And when I multiply there, I'm going to get 6,141. Sum of our first 11 terms. Guys, once we got to this point, you could have just typed that in your calculator as long as you're careful. You could have done it here as well. I would just recommend simplifying this part, because if not, there's a lot of you that aren't forget to put the parentheses here and get the wrong answer. So make sure you either put this in parentheses or simplify it, and then you'll get to where we need to go. Same idea here. So our formula is S of n equals our first term times 1 minus r to the nth power over 1 minus r. And we can get a lot of the information that we need right here. We know our number of terms, okay, is always 20 minus 0. This number minus this number plus 1. So 21 terms. So the sum of our first 21 terms here. Our first number is 4. Our r value is a half. And our n value, we said, was 21. From here, we can go ahead and type this in our calculator. Again, either simplify your denominator here or type it in parentheses. And we should get a value of approximately 8. I think it's like 7.999995 or something like that. Approximately 8. Now let's try the same thing here. The sum of our finite geometric series. So, sum of the first n numbers is going to be our first term times 1 minus r to the nth term divided by 1 minus r. We need to know a few things here. We need to know our first term. Here's negative 15. We need to know our number of terms. Here we can just count them. 6. And we need to know our common ratio. And it says that they're geometric, which means we know that it's going to be the same all the way through. We have all the numbers here, so we could check. Negative 15 to 30, we multiply by negative 2. 30 to negative 60 is times negative 2. Again, we multiply by negative 2 times negative 2 times negative 2. So our common ratio is negative 2. So the sum of the first 6 numbers is going to be our first term times 1 minus our common ratio to the 6th power 1 minus our common ratio. Or you could have done 1 minus negative 2. Either way. Again, some things that we might want to simplify. Negative 2 to the 6th power we could have if we wanted to, but I would definitely simplify here. This one we could do fairly easily without a calculator, but we are going to get, when we type this in, 315. For B, same idea here. We're just going to have to find some more of our values. Our first term we know is 5. Our common ratio is going to be negative 2. And our n value is going to be 10 minus 1 plus 1, or just 10. So, the sum of the first 10 numbers is going to be 5 times 1 minus negative 2 to the 10th power divided by 1 minus r, which is negative 2. You can go ahead and type this in your calculators. Simplify it if you want to. Negative 2 to the 10th power is 1028. no, 1024, sorry. 1 minus that is negative 1023 divided by 3, multiplied by 4. We're going to get negative 1705. And again, this you can type in your calculator. Just make sure you either put parentheses here or add that to 3 first. Example 2 uses a story on page 596, Soldier's Reasonable Quest. A famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on, for all 64 squares of the chessboard. The king decides that the request is reasonable. So in example 2, we want to know, according to the story, how many total kernels of wheat did the soldier request? So we start off with 1, then 2, then 4, then 8. First term is 1. Our common ratio, every time he doubles it or multiplies by 2. And the number of terms is going to be 64 because there's 64 squares on a chessboard, 8 by 8. So the sum here for the total number, again, total means find the sum, is going to be our first term times 1 minus our common ratio raised to the nth power divided by 1 minus our common ratio. 2 to the 64th power is going to be a huge number. So just looking at it right there, you should recognize that this is going to be a substantial amount. So the sum of the first 64 here, or how many kernels that he asked for, again, you can simplify that to negative 1 or put it in parentheses, is going to be approximately 1.845 times 10 to the 19th. And again, the formula we used is the sum based on how many numbers you want is going to be your first term times 1 minus your common ratio raised to the nth power divided by 1 minus r. Now, to save money for a vacation, you set aside $100. For each month thereafter, you plan to set aside 10% more than the previous month. How much money do you save in 12 months? So, our initial amount is $100. Our rate, guys, is not going to be 10%. It's going to be 110%. We're doing 10% more, which means we're taking our original $100 or 100% and adding 10%. So our rate as a decimal is going to be 1.1. It's 10% more than the previous. So 100% of the previous plus 10%. And our number of terms is going to be 12 months. So our sum for 12 months is going to be our first term times 1 minus our rate raised to the 12th power divided by 1 minus our rate. Again, go ahead and simplify or put parentheses in here, but again, you'll get negative 0.1. And we should get, after 12 months, approximately $2,138.43. Please make sure you're typing those in your calculator to make sure that we're getting the right values here. And I will finish the rest on the next video.